Okay, so with this problem, it starts off with this big radical fraction side. The first step I would do is to simplify the numerical part of the fraction. So 5,929 over 1,372. If you keep simplifying, you'll get to this, 121 over 28. Then the next part I would do is to look at the variables and simplify those. So I can see that this a can cancel with one of the a's in the denominator, and this b can cancel with one of the b's in the numerator. So I'm going to get 121 b to the fifth over 28a squared. Now the next step is to rationalize the denominator. In math, we don't like to have a radical in a denominator spot, because this is really, when you have a radical over a fraction, it's really like you have a radical on top and you have a radical on bottom. And we don't want a radical in the denominator spot. So what we can do is multiply by a funky number 1. So I'm going to multiply, as long as I take the same thing on the top and bottom, it's really just like the number 1. So 28a squared, square root, on top and bottom. Then it's really like I'm multiplying by the number 1, so nothing is changing here except for that now on the denominator spot, we're going to have a square root of 28a squared times a square root of 28a squared. When you have a square root of something times itself, the square roots will cancel and you'll just be left with 28a squared here. So that is how I got rid of the denominator radical. But in the numerator up here, I'm still going to have, when you multiply square roots, you can just multiply their insides. Still going to have this, which I need to simplify now. So here I'm going to do a factor tree. That's how I like to do my square roots. I know 121 is 11 times 11. And I know 28 is 4 times 7. But 4 is also 2 times 2. So I'm kind of doing a prime factor tree here. A squared is a times a. B to the fifth is 5b's. I like doing this because then I can just take out my pairs. When you have a square root, that means if you have 2 of something, you can take it out. So I have 2 11s, I have 2 2s, I have 2 a's, I have a couple of pairs of b's, and each of these pairs can be taken out outside of the square root, because once you have a pair of something inside a square root, you can take it out. But once it's taken out, it only becomes one of itself. So my 2 11s is just going to become 11, my 2 2s is just going to become a 2, my 2 a's is an a, and my 2 b's, my 2 pairs of b's are going to become just 1b each. Then I have left inside here a 7 and a b, and I still have in the denominator spot down here a 28a squared. Okay, so now let's try to simplify even more outside of the radical here. 28 I know again is 7 times 4, and 4 is 2 and 2. So one of these 2's can cancel with this 2 up here, and one of these a's can cancel with the a down here. So I think my final answer, if I don't mess this up, I'm still going to have an 11. I'm going to have a b squared on the outside. I'm going to have a square root of 7b on the inside. And I'm going to have a 14a on the denominator spot. So a lot of it was making our factor trees. Some of it was remembering to multiply the numerator and denominator by this 1 so that we won't have a radical in the denominator spot anymore.